So, what are the advantages of 3D printing or additive manufacturing over the traditional techniques? The first advantage would be speed, because it is fast production. That means, from prototype to final products, the design can be developed quickly. The another point in the speed is enables prototype making in few hours compared to large time, few days to few months. It is easily accessible and easy to learn. We will show you the video that we have made of how you can use 3D printing. So, you will understand it is extremely easy to operate. Complex design can be uploaded from CAD model and printed in few hours. It is a single step process. Once you print it, right, you have to just you do not have to do multiple processes, you just wait till printing is complete. It is a single step process. It is cost effective, really low cost compared to the existing traditional techniques. We can create several designs, we can test it quickly, and it is a less waste production. Alright, so there are several advantages. Now let us see how the 3D printing we can use in the laboratory. I will play the video and we will end the module at that particular point. Let me play the video.
Today we will see an interesting equipment that can form an integral part of a lab that deals with translational research. So, what do you mean by translational research? Translational research is that research which the outcomes of your research work finally gets converted or translated, as the word means, into a final product that can go into the market and help people and have a societal impact. So, that is basically translational research. So, when you are doing translational research, you need to look at your research from the point of view of product development. So, even though you will be looking at fabricating sensors, as this course has taught you, and characterizing them and testing them with different types of samples, you should have a bigger picture of what you are trying to do. In the sense, your sensor cannot work standalone. It has to go into some kind of packaging, and the packaged sensor would finally end up as an individual product or would form a part of a system of products. So, in order for you to realize this end product which you imagine in your mind, you need to be able to do something called prototyping. So, what is prototyping? You integrate your sensors or your macro level components of your system that you have designed, and you integrate that in a packaging that is ergonomically designed for ease of use and for environmental friendly operations and several other criterion that are set out for products. For this, an important, so what we have looked at, we told that we will have sensors, we will be fabricating sensors, we will be characterizing them, we will be doing lot of experiments to test their response. Then we will look at how we can make these sensors as a product that can have a societal impact in the population, and it can enter the market or in the actual field, clinical field, because we are looking at clinical applications here. So, before we make a product, we have to prototype the product. So, prototype is the first working, fully functionally working version of your final product. So, your final product would be the one that is sold, but your prototype need not be sold, but your prototype would meet the specifications of your final product with almost 100%, near to 100% faithfulness. So, to prototype such products that integrates your sensors, an important equipment that is very versatile and useful to have in a lab environment is something called the 3D printer. So, you all know about printing. It has been around since you were born. I guess most of you who are looking at watching this lecture would know that it is around since the time you were born. So, printing, what does it do? You put a paper and you will have some source file that you want to be seen as a hard copy. So, your source file will be a soft copy, and you will print whatever is written on your soft copy on a sheet of paper of varying sizes like A3, A4, A2, A1, different sizes of papers are there, using different technologies like inkjet printing, laser printing, dot matrix printing. So, different technologies are there. But at the end of it, what you get, whatever you are trying to convert from soft to hard version, you will get it printed on a 2D material, but basically your A4 sheet. The thickness, the A4 sheet also has some thickness, but that thickness is negligible compared to the other dimensions of the sheet in this, in effectively rendering your printing as a 2D printing. So you print it on an A4 sheet. So basically that is 2D printing. In the last couple of decades, we have seen a surge of new technologies that has been mind-blowing to say the least. And one of the major technologies that have entered the market is what you call 3D printing. So as you have seen 2D printing. So if you can print these 2D layers on top of each other, stack them, you will effectively get what? You will effectively get another dimension, which is the height, and you can actually make 3D printed versions. So when you print something in 3D, you are actually making some material or a form. You will get a form that you can look and feel the depth, length, breadth, everything. So for you to print such a 3D version of your design, if you call, you cannot do it on ink, because ink cannot form layers, multiple layers. So for that you need use specific other materials which we will be introducing shortly. So that is the overall essence of 3D printing. So with 3D printing we will be able to make quickly prototype. That is the main thing here. Quickly you can, whatever you are thinking in your mind, whatever you are conceptualizing in your mind, you can quickly make a design and get it visualized and printed out to see how it can how it will look when it is made as a final product. So for rapid prototyping, it's also called rapid prototyping. For rapid prototyping, you use 3D printer. So the 3D printing is part of a class of technologies called additive manufacturing. So what is additive manufacturing? It's basically you are adding slowly one layer over another to manufacture something that you conventionally manufacture using other methods, like conventional molding, injection molding, and making a mask and then pouring molten material and making it form. Those are conventional methods. Instead of following conventional methods, you use something called additive manufacturing. So what you do, each 2D sheet is stacked on top of each other. Multiple design components in your overall design are added onto each other through this stacking. Finally you get the 3D printed version of your design. So that is additive manufacturing. 3D printing is also some other times called additive manufacturing, and these words are used interchangeably. So there are different versions or technologies in use for 3D printing. So today we will be showing one technology where we take the material, we melt the material at the point of injection where it is deposited, we melt it, and then that immediately solidifies and forms a 2D layer. There is another method where you have your material is in liquid form in a place, and then you develop the material. So what happened by meaning developing, you mean when the material develops it becomes solidified. So you develop the material by using some photo illumination, by illuminating some specific light of wavelength like UV wavelength or IR wavelength. You illuminate the liquid, which is the material, and wherever depending on whether it's a bright mask process or a dark mask process, wherever the light falls, the material gets developed and it solidifies, and the remaining part remains a liquid. So you can take the 3D printed product out. So that is another technology. So there are many other 3D printing technologies. Today we will show you the first technology, which is you have the material that comes into your 3D printer. It is melted at the point where it is deposited, and then once it's deposited as 2D layer, it solidifies, and then it is stacked on top of each other to form the 3D printed version of your design. So without further ado, let's look at the actual 3D printer we have in the lab. So this is the 3D printer we have. It's a very simple and cost effective version of 3D printer that serves the purpose for us in this laboratory to quickly prototype whatever design we want. So now let's quickly look at what are the different components of this 3D printer. So to start off, you have the platform. This red color surface you see, this is the platform where whatever design you have made will get printed. Okay, so because your design will span the X, Y and Z directions, you need motors to control your material deposition. So the material that we have used here is called PLA, called polylactic acid. So it's a white color here. You can see the material. The material is rolled up, and there is a what you call lever that can hold the material in place. So the material is like a wire here. It goes into this extruder. So this pipe takes it into this extruder here. So it is here that the material, this polylactic acid will melt and gets deposited. When we will show you one design, real-time printing of one design, then you will understand what is happening. So the material melts and it gets extruded from this tip and gets deposited here. Okay, so for that extrusion process you need one motor, that is here. And then for other X, Y and Z movements there are individual motors. So for Y movement there is a motor here below, you might not be able to see, it is there below, there is a motor here. Then for X movement there is a motor behind here. Okay, and then for Z movement there are two motors behind here. These are chains to do the XY staging, XY movements. So these are the basic components of the translational mechanism of the 3D printer. So you have a small display to show you how much percentage of the printing is remaining. So if you can see this blue color display. So if you see this blue color display, so this will show once we start printing, you can see how much percentage of the design is pending and how much is done. Now how do we load the design and how do we make a design? So usually the designs are made in CAD using CAD softwares like Pro-E, SolidWorks, etc. So the CAD files are then converted into another format called STL. STL stands for stereolithography. So this is a version of stereolithography actually. The stereolithography.stl file is then converted to something that this machine can understand. So that is called G code. That version is called G code. So the G code file can either be sent through a USB cable. So we have the laptop here, right? So we have one software open here that is for controlling the final printing of the 3D printed version. So the G code file, you can send instructions that are contained, the machine level instructions that are contained in the G code file. You can send it via USB cable here, where it is connected to the back side of the 3D printer, or you can copy your design in an SD card and insert it into the 3D printer, and it will start reading from the SD card and it will start printing. So hope till now it is very clear to you. Now let's see what are we trying to. So let's print something here. So you all remember the indenter that we tried to that we showed you in the session on micro manipulators. We will again print that indenter here and show you how quickly it gets printed and see how much time it takes for it to get printed. You can see it real time when it gets printed. So let's get started with that. We have one more member of our lab here to help us with this. So we have the software. We'll be inputting the design. So he is adding the design. So you can look at the computer monitor. So it's called micro manipulator indenter. So this is the design. So that is the design. He is rotating in all axes to show you all the design. So this is the design that will be printed on the platform. The grid-like structure that you are seeing is in fact your platform's dimensions. So your structure will get printed on the platform of the 3D printer. Now so he can control the printing from this software because it is connected through USB to the 3D printer. So he will start it now. So you can see that there is a print option there. He has made layers of the design here. Now he is going to give print option. So before he starts printing, he has to just oversee the first levels of printing. So if you see the 3D printer, the stage is moving up to start off with the printing. So what happens is the printer will go to its home state or 0 state, where x equal to y equal to z equal to 0, and then align itself. before it starts printing. So it takes little bit of a time to start printing. Let's just see it. So now what is happening is the software is reading the file, the G-code file, trying to predict what all it has to print and where all it needs to do the course corrections in the printing process. So that process you are seeing here, extruder is trying to like that progress is happening. It's heating the material, and the temperature progression you can see in the software here. So once it reaches the target point, it will start. So now let's look at the 3D printer. So you can see the material is melting and coming out from the tip. If you can see this. So the material is melting. So it is testing out how if the material is coming out properly. So once it's clear that it is coming out properly, it is starting the print. So he will just inspect it whether it is starting out properly, and slowly the outside pattern is getting formed. So he will just check it if everything is fine, and then lock the platform. So the extruder is now depositing material slowly. So it will take some, as per the predictions, it will take around 10 minutes, 10 to 15 minutes for it to get printed. Let's wait and watch. We will also try to have a closer look at this. Yes, so the first layer, base layer is formed. You can see the pattern getting formed here. So you can see that it is trying to print it with maximum precision as much as possible. So if you see the display, you can see that estimated time remaining is around 7 minutes 39 seconds. You can see it here. Yeah, and then this buff shows how much percentage is remaining. So how much percentage is completed. So we will see. So there is another display option that shows how much percentage is completed. Either you can see as percentage completion, or you can see as estimated time. So now we are seeing it in estimated time. So now we are just focusing on the printing mechanism. So let's just quickly see the computer monitor once before we come back to this process. So if you see the monitor, you can see a real-time update of what is getting printed being covered on the software also. See, you can see whatever patterns the extruder is making, that is coming as red marks on the software. So this is very interesting. So you can know real-time how your printing is progressing and how each layer is getting formed. So this is the software with which you have to control the printing. So this is not the software in which you make the design. You make the design using conventional CAD softwares like SolidWorks, ProE, etc. And then you have to convert it, as I have mentioned, to STL files. Then the STL files have to be again converted to something that this machine can understand, which is a machine code. It is same as what you do assembly programming in microprocessors. So, but here the machine is different, so the code will also be different. The code will fundamentally consist of what are the XY coordinates that have to be deposited, and then where all the extruder has to deposit material, and how best it can deposit the inner structure. So if you see, the outer structure is coming properly, but the inner one is not actually solid material. It is forming meshes like this. So this way it will actually save little bit of material, so long as you don't want that much rigidity. This is just prototyping, right? You just want to see how your product will look like. So you can have a support structure inside, but need not fill everything with material. So these wells are there, they may not be filled with material, but the outer structure will look smooth. This way you can save some material. So with this material, there are 3D printing materials of varying costs. So this roll that we showed you, that is around 2000 rupees per roll, but there are materials that cost even 2 lakh per roll. So they have their different properties. When they get printed, the smoothness of the surface, the shine, the color options that are given for the material, everything varies. So now let's look at how the printing is progressing. So you can see that the indenter is slowly getting formed, and the estimated time is around 4 minutes now. 5 minutes, 4 minutes 58 seconds. So in another 5 minutes, this printing will get over. So you can see it here. 4 minutes 47 seconds is remaining. So the extruder is printing very fast. So this is a 3D printer that we have assembled in the lab. Actually, we have procured the individual components of the 3D printer, and the enthusiastic members of our lab have actually assembled the 3D printer together, because of which we were able to make it work in much cheaper cost, even 1/10 or 1/50th of the actual cost of 3D printers that are available. So it's getting printed. Now earlier we came close to the machine. Now because it has formed enough, you will be able to see it from far also on the platform. So we will wait for it to finish. It is looking like white. So the material, so you have seen that it is getting deposited as white color. So you have other color options also, like gray, black, blue, and they have different price ranges. So in case you want to make, whatever 3D printed prototype that you make, they may not be of a single part. You might have to fabricate different parts and then assemble them together. Once this is over, we will also show you another pattern that we have made in the lab to make you understand that you can make working prototypes using multiple 3D printed parts. So if you are someone who has an aesthetic tendency and you want to have different colors in your product, you can actually get your multiple products printed using material of different colors. Like you can use black and white, blue and white and all, to make your product look much more like a product and much less like a prototype. So it's getting printed, but one problem is that preferably you will use the same technology, right, to print the multiple parts of your design. So you might have to use the same material for all your individual parts. You can also go ahead by printing, integrating different materials, but you would need those different types of 3D printers. So only cost would be a consideration there. But if you want to just get it done and see how it looks like, this is more than enough. So in another 2.5 minutes, this printing will get over. So I have told you that so our sensors are very delicate materials, as you would have understood during the course of this course, and they are very fragile, brittle and all, and they need to be handled very carefully. So the packaging of sensors that we have seen till now is very important. So once they are packaged, as I have told, they have to be nicely enclosed and they have to be introduced to any potential customer in the most aesthetic manner. So for that, a 3D printer is very much important in any lab, and labs in India are slowly gaining their trying to understand the importance of having 3D printers within their lab spheres, which is a good thing. So now you can see that almost the structure is formed nicely. Same indenter which we saw in micro manipulator is here. So in under 2 minutes it will get over. So once it gets over, you should observe. So immediately once it gets over, the extruder goes up. The platform, not extruder goes up, extruder stays there. The platform immediately drops down like a fall. Then you will know that your printing is completed. So because ours is not a very high-end 3D printer, it's very important that we need to have a continuous power supply. In case supply goes while it is getting printed, it doesn't have memory to restart printing. So that is one shortcoming. So higher grade printers have that option. So it's better that you have a backup power supply for these printers. So when it's about to get finished, we will focus back again on the printer and you will see the platform dropping down. So that is the thing. So I hope this video showed you how important 3D printing is and the versatility and utility of having such an equipment within your lab space. I think this is going to get over. Let's just see it. The printing is about to get over now. It's around 40 seconds away. So you can see that it has nicely formed like Milky Bar, white color, and so it's about to end. Let's just wait and watch now. I will not speak now. So as soon as it's over, the platform will drop down. And the control system in the printer makes sure that always the material gets melted at 200 degrees Celsius around and gets deposited. So those are all control system details. So it's about to end. In 8 seconds it will get over. He's doing the finishing touches. If you see the outer surface now, it has made it smooth, all outer surface. Inside, when you had seen, it was all meshy. Now that mesh structure is not there on the outer surface. So it has fallen down. The printing has ended. You can see that the structure is formed nicely on here. Now it is stuck to the platform. Now we have to remove it. So let's see how he removes it. So it is removed. So this is our final 3D printed intender. This is the same intender that we saw with our micro manipulator. Clear? Nice, right? In under 10 minutes it got printed. We have something solid in our hands which we can use. It's very solid, nothing will happen. To a reasonable extent it's very strong, so you can handle it with good roughness. So let's see one more thing that we have printed here. I was telling you that we can use multiple parts, right? Multiple parts to make a 3D printed system. So this is like it's a mechanical aperture. So you might have seen similar mechanisms in camera lenses. So if you rotate it here, it will open up. And if you do this, it will close up. Okay, so let's see how many parts are there in this. This top part is there, top circle, there is one part. Same way there is a bottom part, second part. Then there is this controlling lever mechanism here, which I am rotating. There is a third part, and there are leaves here inside. If you see closely, there are leaves. There are 9 leaves, which have been printed separately. So total 9 plus 3. There are 12 separate parts that are printed on a 3D printer and then integrated, put properly, aligned, and then attached with screws to make a final working prototype of a mechanical aperture. See, this is what happens. So we have seen how 3D printing is done basically. So what I was talking to you was, this is a course on fabrication, right? So during the course of this, during the journey of this course, we have seen several micro fabrication techniques. But if you look at it, this is also fabrication. But this is not micro fabrication. This is, you can say this is macro fabrication. You are fabricating stuff. Physically feel, you can have stuff that you can physically feel, just like your micro fabricated sensors. So introducing you to this technology, many of you might be already exposed to this, but we wanted to show you how it is exactly printing it. Introducing you to this technology will give you a holistic idea about fabrication, and fabrication need not necessarily be micro fabrication, but that is the focus area of our course. But fabrication is a very general term. You can always have macro fabricated components that will house your micro fabricated sensors. So we hope that this video will make you think. Every time you make a system, or if you make a very small sensor also, you should always look at how your sensor can go to your society as final products which they can actually use. So preferably, not always, it is not possible all the time that we have to accept, but whenever possible or as much as possible, you should make sure that your design is translational. whatever research you are doing has final end value to the society, and you can make the world little bit more a better place to live. Thank you.
Okay, so in the video you have seen how we have used the 3D printing, and you have also seen as a live experiment that what kind of 3D printing material we can print. You can print several different designs. Again, if you have more questions on 3D printing or which kind of parts or material you have to use for your particular application, feel free to ask us, we will help you out. It is very easy to learn CAD models. Generally I prefer SolidWorks. However, there are several software that are available as mentioned in my previous slides. Feel free to use whatever you it's comfortable for you. The point is to create a STL file and we can send it for the printing purpose, right. So, again the 3D printing is very small part of the overall course. It is just to give you some understanding about the technology available for designing a casing for the instrumentation. Alright. So, we will see different modules about either sensors or on the lithography or on the clean room environment, right, that we have already seen how the clean room looks like, and what are the processes to follow when you enter the clean room. We have also seen the silicon wafers and silicon dioxide, how it can grow on silicon and what is the use of the substrate, right, and we will take it further. Like I said, we will be stressing more on experiment side, where I will be showing it to you or my TA will be showing it to you. When I say my TA, they are my students. The TAs are working with Dr. Mahesh. So, they will be showing it to you how the electronic instrumentation can be used in real time, and we will show you by acquiring the signal, EEG signal from the scalp and showing you on the display. So, this entire focus on experiment side is also there in this particular course that we will be looking at. You again look at the videos. Any question, feel free to ask us. We will help you by answering through the NPTEL forum. Till then, you take care, have a nice time.